Well, hello again and welcome to the VK6ES Fun with Amateur Radio channel. I'm just looking at the HT rail with absolutely no load on it whatsoever. The valve's not running, there's no idle current. There's only a few milliamps being pulled through the bleed resistors that are across the smoothing capacitors. And I was looking at that and I thought, to get the 4000 volts, I'm having to put in just a little bit more than 240 volts. Not much more. Looks like about 2.5 volts more on the AC side to get the 4000 volts on the mechanical meter. So I thought, well, I wonder if that's actually true. Is it the meter? Not that it matters, of course. A few volts here and there. But when I plug it into a meter with a digital display, I'm having to put in 244 point... Oh, it's gone up a bit now. The mains voltage fluctuates here, that's the problem. So I set it up for 240 volts, it turned around and it's... Oh, now the meter's timed out, I can't believe it. Okay. There we are. Okay. So, actually that's what I said, wasn't it? It was about 2.5 volts. So there we are, 242 point, I don't know, call it 5 as it's sort of jumping around a little bit. I said 2.5 volts, that'll make me right then, won't it? So to get the 4000 volts, unloaded HT line, I need to put in an extra couple of volts. But if I turn that down to 240, there we go. I get 3,970 volts. So that's the HT rail completely unloaded. So that's far more manageable. So I can cut the valve off entirely on receive. It's 5,400 volt working voltage across the capacitor stack, so there's plenty of headroom there. By cutting the anode current off completely on receive, the voltage doesn't skyrocket to something unmanageable. It goes up to just a tad under 4,000 volts, which is all nice and comfortable. You can see the mains voltage fluctuating there now, can't you? That's probably next door's solar array doing all that sort of thing. Now I've got the HT disconnected from the valve. See the Jubilee clip is not there, and the parasitic suppressor that normally goes from the end of the choke there to the valve is missing. I'm just taking that off so that there's no HT on the valve. As you can tell, the fans and the heater's not running anyway, so I wouldn't be putting HT on it without those running. And I thought it might be a little bit of a novelty to talk on one of these videos, and you could listen to me without the rushing noise of the fans in the background. The other thing I've done, just as a temporary measure, I don't know how this is going to work, is I have just taken a couple of wires out of the box under the PA module and put a Zener diode on there. It's a bit on the small side, but I've only got a couple of small Zeners. I haven't got any 5-watt ones. So whether it'll smoke up or not, I don't know. I haven't actually sat down and done a calculation. I think these are 1-watt ones, I'll be surprised. It's only a transistor base after all. So that I can fiddle around with the bias and get the anode current, the idle anode current right, without keep taking this bloody box off. There's a pain in the rear end taking the box off. And yes, you'll notice that I have put some pants on. I have got changed, so no need to cover your eyes anymore, madam. As you saw on the previous video, 1400 and a bit watts out of it, 1450 maybe. It's still got a bit of a way to go. I think I've seen people getting 1.6 or 1.7 kilowatts out of these with 3,200 volts on them. Now, when that was sagging down, because that transformer there is, you know, it's even though it's a voltage doubler, it's keeping it pretty stiff. So it's dropping down to still 3,500 volts ish. So that's more voltage than I've seen people achieve a higher output with. So, you know, when it's optimized and the efficiency is improved, I should be able to get a bit more than 1,500 watts out, and hopefully have a little bit of play on that loading capacitor, so it's not fully meshed all the time. All right, well, I don't know if I showed you the HT transformer, did I? There we go. It's just sitting on a plastic pot there. That looks a bit fudgy, I know, but it works. It's just a way. That's just the meter probe showing me the AC input to the transformer, and the little flags, of course, on the secondary there. I just tested the no load AC voltage and just flagged it with some masking tape, and the actual. I'm using the two outer wires there, the 0 and the one closest here, closest to me here, going up to a ceramic terminal block. So that's the arrangement, and that's what I'm getting with it. Okay, well, I'll wind that off, turn that off, let that discharge, and then I think I'll probably put the anode connection back on, and have a bit of a fiddle around with the bias, and see what I can do with it. I might even try that other tank coil. Might take the front panel off and measure the inductance of this coil here, and get something close to that inductance on the new coil, and have a bit of a play around with that. Well, okay. As always, hope you found that interesting. Thanks for watching. I'll catch you next time.